Okay, so we are going to graph sine and cosine. This is example 2. So we are given y equals sine of 3x. So our amplitude is still absolute value. We have a invisible 1 right here, so it's just absolute value of 1, so that's 1. So our max equals 1, and our min equals -1. Our period is 2 pi over b, so it's 2 pi over 3, because our b is 3. And then our phase shift is this thing, and then you have to set it to 0 and then solve for x. So it's 3x equals 0 divided by 3. So we have no phase shift because it's still 0. No phase shift. No phase shift. Okay, so our range is from -1, our minimum value, and our maximum value, so it's -1 to 1. Okay, so start graphing. So here's 1. Here's -1. So our period is 2 pi over 3, so here's 2 pi over 3. So we need 3 points right here, 1, 2, 3. So we have a total 1, 2, 3, 4, and 0. So that's a total of 5. 1, 2, 3, 4, 5. Okay, so to find this, what you do is, to find the critical points, you simply just do the period, which is 2 pi over 3. Divide that by 4. So I'm going to do brackets, and I'm going to multiply that by 3. So I should get so that's 2 pi, and then multiply 4 pi is 12, and that simplifies into 12 pi divided by 2 is 12 divided by 2 is 6. So basically, here's our first point, is pi over 6, and then you keep adding pi over 6. So pi over 6 plus pi over 6 will give you pi over 3, and then pi over 3 plus pi over 6 will give you pi halves. So you're basically adding, what is pi 6? Pi 6 is 30 degrees, right? Pi 6, pi 4, yeah. So you're adding 30 degrees each. So pi 6 is 30, and then 60, 90, and then 270 is, and then 120. Okay, so when you plug in pi 6 into the function y equals sine 3x, you will get a positive 1. So this is pi 6, comma 1. When you plug in pi over 3 into the function, you should get 0. So this is pi 3, comma 0. When you plug in the function pi halves, you should get -1. If you, yeah, I already done the work, so I know it's right. But if you're just starting out, just do the work. So pi halves is, so this is pi halves, comma -1, and then 2 pi thirds, it will give you 0. And then over here, the 0, 0 will still give you 0. So when you graph it, it should look something like this. So we know our range is from -1 to 1. Our period is 2 pi over 3, and we don't have a phase shift. And then we can also say it's a horizontal stretch. By a factor of 1/3. So that's one problem. So I'm gonna erase. So if you need to save, press pause. Our next problem is y equals 2 minus sine x over 4. What I'm going to do is rewrite it again. I'm going to rewrite it as y equals negative sine x plus 4, x over 4 plus 2. So our amplitude is absolute value of -1, right? Because there's a -1 right here, equals 1. But we have a vertical shift. So we have a vertical shift of +2. So our max is 1 plus 2, 3, and our min is -1 plus 2, which is 1. Let's do a phase shift. So our phase shift is 1/4 x equals 0, and then x equals 0. So there's no phase shift. Okay, so we know our period is, okay, what about our period? Is 2 pi over b. So it's 2 pi. Our b is 1/4. So it's this whole, there's like an invisible one, so that's how I got 1/4. And when you do the work, you should get, you can multiply everything by 4, and then you should get 8 pi. Okay, so we get 8 pi. So to find our critical points, you take the period, which is 8 pi, right? 8 pi, and you divide it by 4, so you get 2 pi. So let's graph it. So we said that our max is 3, so here's 1, 2, 3, and our min is 1, so here's 1, here's 3. Our period is, where did we say our period? 8 pi. So here's, we need 3 more points, 1, 2, 3. So we got to start at 2 pi, right? Because we don't have a phase shift, so this will be 2 pi. And then you add another 2 pi, which is 4 pi. You add another 2 pi, which is 6 pi, and then until you get up to 8 pi. So when you plug in 2 pi into the y function, y equals negative sine x, negative sine times x over 4 plus 2, you get 1. So right here, so this is 2 pi, comma 1. For 4 pi, we get 2, positive 2. So this is 4 pi, positive 2. For 6 pi, you get positive 3. And for 8 pi, you should get positive 2. Positive 2. And then for 0, you plug in 0, you should get positive 2. So that's 0, 2. So it should look something like that. And our range is from 1 to 3. So that's it. And then our last problem for our sine graph, so I'm going to erase it, is our last problem for sine is y equals sine of pi third x. So amplitude is absolute value of 1, right? Because there's a 1 right here. So our max is 1, and our min is negative 1. So our range is from negative 1 to positive 1. Period is 2 pi over b, which is 2 pi. Our b is pi thirds, right? Pi third. When you do the work, or you could then you multiply everything by, put it by brackets and multiply everything by 3, and you should get 6 pi over pi, which is just 6. Okay, now do we have a phase shift? So our phase shift is pi third x equals 0, and then so we have no phase shift. Okay, so now let's graph it. So our range is from 1 to -1. And then to find, we gotta find our critical points. So we said our period was 6, and then you divide that by 4, which is 6 divided by 2 is 3, and then 4 divided by 2. Okay, so our period is 6, so here's 6. We need 3 more. 1, 2, 3. So our first value is going to be 3/2, and then add another 3/2, which gives you positive 3. And add another 3/2 will give you 9/2. Now just plug in the points. So when you plug in 3/2 into the function, so when you plug in 3/2, you get positive 1. So this is 3/2, comma 1. When you plug in 3, you get 0. Now remember, this is only one cycle. If you wanted to do the second cycle, you could do -3/2, -3, etc. Okay, so when you plug in 9/2, you get -1. So this is 9/2, comma -1. And then when you plug in 6, you get 0. And then don't forget 0. So when you plug in 0, you still get 0. So let's graph it. So that's our graph. That is our sine graph of sine of pi of 3 over x.